This is Sriparna, and currently we are discussing about the intelligent agents. So far we have discussed about the introduction of the intelligent agents. Then we have discussed about the different concepts for agents. And today we are going to discuss about the types of environments. If you haven't subscribed till date, please do so for regular updates. So let's start. So the environments or the task environments. So the task environment basically are the problems, the architecture of the environment, the parameters of the environment that makes the environment problematic, while the rational agents are the solutions. Oh, you don't know about the rational agent? Please refer to my last lecture. I have thoroughly discussed about the different concepts for agents. There was the rational agent concept, omniscience, learning, autonomy, all the concepts have been explained. So please refer to that. Now, if we need to specify the task environment, we need to maintain a PEAS description as fully as possible. So, PEAS, P stands for performance, E for environment, A for actuators, and S for sensors. This is PEAS. On the right side, you can see the picture of a car. You might think this is just to give you a funky look. No. We are going to describe these environmental parameters, that is the PEAS, in terms of automatic cars. Right? So, the example is currently automatic car. Now the first is the performance. So the measurement of performance. So that is how can we judge the automatic car, and what are the factors are to be considered. What are those? There can be several factors, but currently we are considering about the 5 factors. Getting to the correct destination, minimizing the fuel consumption, minimizing the trip time and cost or cost, minimizing the violations of traffic lights, traffic laws, minimizing the safety and comfort. These are the main 5 factors that need to be considered while measuring the performance. Now, PEAS. So E stands for environment. The environment is, that is the automated car or the taxi must deal with a variety of roads, traffic lights, other vehicles, pedestrians, stray animals, roadworks, police cars. These are all the environmental factors that, and also not only that particular environment, here the environment is also about the customer. Suppose one customer has boarded one particular automated car. Now that will be inside that particular agent, right? It will be seated inside the car. Now it might say that is, no, I don't want to the location I have given in your app. I want to just please take the car rightly. I have seen one friend is there in the other side of the road. I want to meet that friend. So stop the car right now. So this is, he has told in its natural language. So the automated car should process this natural language. That is the NLP, natural language processing, should be there to understand he is wishing to stop the car right now. So it's going to stop the car. So that is the interaction with the customer. So not only the traffic lights that it need to obey, not only the other vehicles and pedestrian and stray dogs, to understand it is not colliding with them. Also the roadworks, you need to understand where the road is there. So roadworks is going on, I should not go by that particular lane, I should take a turnabout. Also the police cars, it should not only consider about those parameters, but it should always interact with the customer. What is the needs? Suppose the customer wants to be AC to be much on a higher side, so it should do that. So these are the environment for the task. Now A stands for actuators. Basically these are the outputs, that is the control over the accelerator, steering, gear shifting and braking. a display should be there to communicate with the customers. And the sensors, so these are basically the inputs for the agent, that is to detect other vehicles, road situations. And the GPS, that is the global positioning system, should be there to know where the taxi is. So by following the GPS it can reach to the correct destination. And many more devices are necessary. What are the devices? Ladder, radar, these are the devices. It should know that where the other car positions are there, where the roadworks are going on. So these are the sensory information it should collect. So that is, it should not only have one particular sensor, that is one particular device, that is a GPS. It should have many other GPS, many other sensors like or similar to GPS or along with the GPS to perform well in the particular task environment. Now, the properties of task environments. Environments can be divided into different, based on different concepts. One concept is about the observability. So that is the fully observable. When we can say that one particular environment is fully observable, if an agent sensors give it access to the complete state of the environment at each point of time, then the environment is fully observable. That is, if we can completely understand the state of the environment at each particular time, then the environment is fully observable. Now, when the environment will be partially observable, an environment might be partially observable because of noisy and inaccurate sensors, or because parts of the state are simply missing from the sensor information. The missing can be done by some noise, or it can be missed by not taking properly sensory data. So based on that, environment can be partially observable. Just one example, a local dirt sensor of the cleaner cannot tell whether the other squares are clean or not. That is, the information about the other squares are not observable correctly. So that makes the environment partially observable. Now, one concept about this fully observable. Suppose you are playing a chess game. So what is the position of each of the pieces of the chess is completely observable in each particular amount of time. So then the scenario is fully observable. Now the environment can be divided and say whether the environment is deterministic or stochastic. Next state of the environment completely determined by the current state and the actions executed by the agent, then the environment is deterministic, otherwise it is stochastic. That is, the if one particular state, suppose one agent is in particular state, and that particular state you can completely design based on the current state and the previous actions the agent has already been executed, then we can say it's a deterministic environment. Otherwise we are going to say it's a stochastic one. Now the environment can be of strategic, that is deterministic. The strategic environment is deterministic except for actions of other agents. Okay, so the example of a stochastic environment is, that is the vacuum cleaner and the automated car. These are the examples, that is these agents are performing in the stochastic environment. That is, here there are some unobservable aspect. Why? Suppose it's an automated car, you are driving the car, but currently do you know from which side the pedestrian will be there, which side there will be another car? There will be some missing information about the environment. You cannot completely determine your next state based on your current state. There can be some way some stray animals might come in front of your car. So that is, these makes the environment stochastic, as there are some unobservable aspects. After this, these there are about the environment that is episodic, or the environment can be sequential. Now one episode, that is an episode that is described by the agent's single pair of perception and action. That is the perception that is for the sensors and the actions that are by the actuators, that makes the agent, or that makes the particular pair, that is the perception and the action, that makes that this particular pair is one particular episode for one particular agent. The quality of the agent's action does not depend on other episodes. If that was the scenario, that is, that particular environment is episodic. That is, every episode is independent of each other, and this makes the episodic environment much simpler, and the agent does not need to think ahead. That is the episodic environment. And the environment will be sequential when the current action may affect all future decisions. Example, automated car, that is the taxi driving, and the chase, that are the examples of sequential environments. That is, one particular piece you have moved in the chase game that will affect all the future decisions that you are going to take in that environment. So that environment is a sequential one. Now let's talk about the properties of task environments that make the environment static or dynamic. A dynamic environment is always changing over time. That is, the number of people in the street you don't know from before. That is, it can be 0, it can be 1000. So that is a dynamic environment for the automated car. And what will be the static environment here? That is the destination. You need to reach to one particular point, right? You need to come to, suppose you are in the office, you need to come to your home. So that is the destination. That is the static environment. Now, another environment can be semi-dynamic. That is, the environment is not changed over time, but the agent's performance code does. That makes the environment semi-dynamic. Next, we are going to talk about the discrete versus continuous environments. If there are a limited number of distinct states, clearly defined percepts and actions, the environment is discrete. Otherwise, the environment is continuous. For the discrete, its example is the chess game. It's a composed of distinct states, and it have been defined by the percepts and action. But the automated car in or the taxi driving is an example of a continuous environment. Why? Everything is moving in a continuous speed. You cannot fix, or you cannot define the state distinctly. It's in a continuous motion. So that was the example of continuous environment. Next, we are going to talk about the single agent versus multi-agent environment. Playing a crossword puzzle, that is the example of single agent. And the chess playing by two agent, that is the example of multi-agent. That is, how many agents are there, that makes the environment single agent or multi-agent. Now the multi-agent environment can be of two types. One is competitive, another one is cooperative. When the environment will be competitive in nature, when both the two agents are competing to win the scenario. That is, in the chase, both sides are trying to win. So that makes the environment a competitive multi-agent environment. And for this particular competitive environment, one important search technique is adversarial search, that will be discussed in the later videos. A complete understanding, I hope you are going to get a complete understanding about the adversarial search by listening to my future videos. So that was the competitive environment. So another type of multi-agent environment is cooperative. That is, we are there are two agents are there, or it can be more than two agents, but they are helping each other, that is they are in cooperation. That can be one example is, suppose it's an automated car, so this car will try to avoid collision, and all the other cars in the road, all of them will try to avoid the collision. So that is the example of cooperative multi-agent environment. Now let's talk about the next type of properties of task environments, that is the known versus unknown. This distinction refers not to the environment itself, but to the agents or the designer's state of knowledge about the environment. In known environment, the outcomes for all actions are given. For example, solitaire card games. And if the environment is unknown, the agent will have to learn how it works in order to make good decisions. One example is new video game. You are playing a new video game, you do not know what will be there in the later on stages of the game. The scenario of the game can be changed, there can be different enemies will be introduced, different weapons can be given to you, that is it will going to change, that is the unknown environment. So this is all about the types of environment, and later on we are going to talk about the last topic of intelligent agents, that is the types of agents. So this is for today's lecture, and thank you everyone for investing your time. Keep subscribing and happy studying.